of a figure. Looking at the concept map for today's lesson, we are going to be looking at the area of polygons and circles, where we are going to start with triangles, then we're going to move on to quadrilaterals, then we're going to move on to circles, and lastly, we are going to end with our compound shapes. So let's look at the pre-knowledge for this lesson. So for this lesson, you should know how to determine whether a triangle is a right-angled triangle or not. Use the theorem of Pythagoras to calculate a missing length in a right-angled triangle. Calculate the area of rectangles and triangles, and the different types of triangles and quadrilaterals. So these are all the things that we must know for this lesson. So let's move over to some practice. We have here, determine if the following triangles are right-angled triangles or not. So looking at the first triangle there, so we are trying to determine whether it is a right-angled triangle or not. So when we are looking at this triangle, it's just a normal triangle, but we do know that if it were a right-angled triangle, then the longest side, which would be the diagonal side there, that would be equals to this side squared plus this side squared. Now that is what Pythagoras says. So we need to check if this is so. Now we are looking at 13, and if we square 13, that is going to give us 169. So we now need to see if the sum of the square of these two sides is also equals to 169. So let's calculate that quickly. Now if I have here my 12 squared plus 5 squared, we know that 12 squared, which is 12 times 12, is 144. And 5 squared is 5 times 5, which is 25. So I have 144 plus 25. And what is the sum of those two numbers? It is 169. So since as well the sum of the two sides is equals to, the sum of the square of the two sides is equals to the longest side squared, then that means that this triangle is of course a right-angled triangle. And we know that's how they indicate whether a triangle is a right-angled triangle or not. Let's move on to the next one. So what we have here is another triangle that we need to determine whether it's a right-angled triangle or not. So we are going to look for the longest side, and the longest side is this side over there because it is 20 there, we can see. And then we need to figure out if this side squared, so that is 20 squared, and 20 squared is equals to 400. And then we want to see if the sum of the square of the other two sides is equals to 400. So that means we are going to take 10 squared, and we are going to add 15 squared, and then we are going to see how much that is. So 10 squared here is 100, and 15 squared is 225. So what is 100 plus 225? That is 325. So we can see that it is not equals to 400. So what does this mean? It means this triangle here is not a right-angled triangle. Let's check this last triangle here, whether it's a right-angled triangle or not. Now the longest side here is this 17. So we need to check if the square of the longest side, so that is 17 squared, which is equals to 289. We need to check if the square of the other two sides is also equal to 200, the sum of the square of the other two sides is also equals to 289. So that is 8 squared plus 15 squared. Now 8 squared is equals to 64 plus 15 squared, which is equals to 225. So what is 225 plus 64? That gives us 289. we can see that it is giving us the same answer as the longest side squared. So is this a right angled triangle? Yes, in fact, it is a right angled triangle. Next, we are going to now find the missing side in the following right angled triangle. So we have here two triangles. So we're going to start with the first one there. So we have 10 centimeters on the hypotenuse, and we know it's an hypotenuse because it is opposite the right angle. So we have 10 centimeters there, and then we have 8 centimeters for the one side, and we need to calculate the missing side. So because this is a right angle triangle, that means that we are going to use Pythagoras to find the missing side. So Pythagoras says that 10 centimeters squared should be equals to one side squared plus the other side squared. Because we don't have a value here, we can use a variable. So I am just going to use x there, but we know that whatever number is supposed to be there, it must be squared. So 10 squared is going to give us 100 centimeters squared, because 10 times 10 is 100. And then 8 centimeters squared is going to give us 64 centimeters squared. And of course, we have that unknown there. So because we are looking for our x, then we are going to take this 64 centimeters squared and subtract it from the 100 centimeters squared. So now we have x squared is equals to, what is 100 minus 64? That is 36 centimeters squared. And then what would be our answer here? We know that x will be equals to a plus or a minus. Let's just write it on this side. We know that x will be equals to a plus or a minus 6 centimeters. But because we are working with length, then we are going to just say there x is equals to 6 centimeters. Let's move on to the second right angle triangle, where we are also going to be finding a missing side. So we have been given 3 millimeters for this side, and we have an unknown side here, and then of course the hypotenuse there as 5 millimeters. Remember, we always see the hypotenuse by the one that is opposite the right angle. So then we are going to start with the hypotenuse, because remember, Pythagoras says that the hypotenuse squared will be equals to the one side squared plus the other side squared. Since as well we don't know what the value of that side is, I'm just going to use a y to represent that unknown value. So 5 millimeters squared gives us 25 millimeters squared. 3 millimeters squared would give us 9 millimeters squared. And of course, we have the unknown value over there. So for me to find that unknown value there, we are going to subtract 9 millimeters squared from the 25 millimeters squared. So what is 25 millimeters squared minus 9 millimeters squared? If you are thinking of 16 millimeters squared, then you are absolutely correct. And as we know, if we are looking for an unknown that is squared, if it's equals to 16 there, then it means that the unknown is a plus or a minus, or should we say a positive or a negative 4 millimeters. So because we have to choose one, we are working with length. Therefore, that means that our y is equals to a positive 4 millimeters. Let's now look at the keywords that we are going to be using during this lesson. So we are going to look at area, which is the size of the surface or a space. Then we are also going to be using perpendicular height. That is a height that meets the base at 90 degrees. Then we have the circumference, which is the distance all around the edge of the circle. The perimeter of a circle. Next, we have the radius, which is a straight line drawn from the center of the circle to a point on the circle. Then we have the diameter, which is a straight line through the center of the circle that joins 2 points on the circle. Its length is twice the length of the radius. And then lastly, we have the center of a circle, which is a point inside the circle that is the same distance from all the points on this circle. So these are the keywords that we are going to be using in today's lesson. Let's quickly go for an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So now we are going to be looking at the first concept in our concept map, and that is triangles. Remember, we are working with the area of polygons and circles. So we're firstly going to look at triangles. Now, the area of a triangle is calculated using the base of a triangle and the perpendicular height of that triangle. The base and the perpendicular height form a 90 degrees angle. So we need to make sure we know where the height is. So let's start off with a right-angled triangle. So when we're looking at a right-angled triangle there, we have BC as our base, which means that the height needs to be perpendicular to BC. And in this case, we can see that AB is the one that is perpendicular to BC. So BC is the base and AB is the height. Then we look at an acute angled triangle. Now, an acute angled triangle has its base also perpendicular, to the height. So which one is the base in this case? So now we have the whole of QS as the base of our triangle. And since that one is the base, now the height has to be perpendicular to that base. We can see the height going there from the highest point in our triangle to the base, and that would be the height of this triangle. What about an obtuse angle triangle? Now, as we can see there, we have the base as MN. So the base of our triangle is MN, right? But because we know that the height needs to be perpendicular to the base, and the height is from the highest point, which in this case is L. So it's from the highest point and it needs to go down to the base. But because where it is going down perpendicular. Hello learners, and welcome to today's lesson of the area of polygons and circles. Let's start off our lesson with a did you know. So did you know that a square. Hello learners, and welcome to today's lesson of the area of polygons and circles. Let's start off our lesson with a did you know. So did you know that a square is just a special rectangle? A rectangle is a shape with two opposite equal sides, and that is exactly what a square is. A square has 4 equal sides where 2 opposite pairs are equal. Let's look at the lesson objectives for this lesson. So by the end of the lesson, learners must be able to use appropriate formula to calculate the area of quadrilaterals, circles, complex figures, and the shaded areas of a figure. This is our concept map for today's lesson. So we are going to be looking at the area of polygons and circles. So we have there triangles, which is going to be our first concept, then quadrilaterals, and then we're going to move on to circles, and lastly we are going to look at complex shapes. So for this lesson, you should know how to determine Hello learners, and welcome to today's lesson. Hello learners, and welcome to today's lesson of perimeter of polygons and circles. Let's start off our lesson with a